Okay guys, we just got our RIP version 6, or I'm sorry, RIP version 6. We just got our RIPng environment up and operational to work with IPv6. Now, the CCIE Routing and Switching version 5 exam is all about verification, being able to do diagnostics. So what I want to do right now is I'm going to do an extremely short video where we're going to focus on how would I look at what's taking place on these segments. So what I'm going to do is I'm going to use a debug. Let me go ahead and I'll clear this out right here. And I want to just execute a very simple debug command. I'm going to say debug IPv6 RIP, a command that we're very familiar with regard to how our systems were working with IPv4. All we're doing is just adding the IPv6 configuration to it. So let's watch and see exactly what happens as information gets exchanged between these devices, if anything shows up at all. And we can actually see the fact that now we are exchanging information. So let's see here. I'm going to say you all. And what I want to do is I want to look at what's happening here. So let's see here. We've got RIPng messages. And what we're doing is the process, RIPng, is sending a multicast update. We're sending it, and it's being sourced from FE80::22, and notice the destination was FF02::9. Well, what does that mean? So if I take a look at this, anytime I see FF in the first two fields of a IPv6 address, we know that's multicast. And notice it's going to 9. So FF02::9 is going to be a link local IPv6 multicast that's going to be the same address pretty much as 224.0.0.9. The multicast address that we use to extend communication in our RIP configurations, RIP version 2 that was built to work with IPv4. So again, notice it's still using the .9. So once again, this is going to be one of those instances where remembering something from our IPv4 is going to make working with IPv6 routing protocols easier. And we're going to find that's going to be the situation on a case-by-case basis as we entertain each and every one of these routing protocols. So looking at this, we see also some additional information. Notice it's using, and I'll go ahead and clear my chicken scratch here. Notice that it's using source port 521 and destination port 521. So where IPv4 used 520, IPv6 RIP or RIPng uses port 521, both as the source and as the destination port. And also notice that we're exchanging information about our individual prefixes. And we sent this. So let's take a look and see some of the other things that we might be able to see here. All right, so let's scroll down just a little bit and see what the system tells us. Well, here we're sending. Notice right here, we received a message. Now, what's going to end up happening here is the message we sent here, this is going to be related to our loopback 0, and it's going to be for RIPng. So what we're going to do is it's going to be basically received our own process, which means we're going to be ignoring that. Now, looking at how the system is going to operate, what I also want to do is I want to see if I can fire up a trace. So what I'm going to do is, just bear with me one moment, I'm going to go over to my Wirecast config, and what I'm going to do is I'm going to enable or turn Wirecast snooping on some of these interfaces. So just bear with me one moment. Let me go ahead and enable that process. Now we obviously have to wait, but what I want to do is I want to see diagnostics associated with IPv6 and IPv4, because keep in mind, in this environment, I'm still running both protocols. If I do show IP protocols, we're going to see that I'm still running RIP for version 4, I'm sorry, for IPv4, and I'm also running RIP for IPv6. So I can do show IP route RIP, and I'm learning, well, right now I'm not learning any prefixes. Let's see here, show IP route. Let's see, I'm not learning anything. What's going on here? show run interface E serial 20, show IPv6, show IP interface brief. E assigned. All right, right now I'm not learning anything. Let's go over here and take a look at what's going on. Show IP route. So I'm learning RIP routes here. Show IP route RIP. Let's go over to R2. Show IP route RIP. Learning prefixes here. Let's go over to R3. Show IP route. RIP. Learning RIP prefixes here. Show IP route. I'm not learning any routing processes here. So show run section router. RIP 200.7.2, no auto summary. Everything's good to go there. Show run interface serial 20. Nothing there that would lead me to believe or see that anything is a problem. IPv6 RIPng enabled. Show IP protocols. Well, this says I should be advertising those. Let's cut over to R2 and see what's going on. Show run interface S01, sorry, S20. See, I've got my RIP address, my IP address. I've got my advertise configured. Let's take a look at my routing protocol. Do or show run pipe section router RIP. And let's see what we got going on here. We've got version 2. Timers are configured properly. Auto summaries configured. Let's go over to R3. See what's going on. Show interface serial 21. Show run interface serial 21. Okay. RIPng is enabled. Let's take a look at my routing process. Show run section router RIP. No auto summary. Everything seems to be good to go here. So maybe we've just got something going on with the platform. So let's do this. Config T interface serial 10 or 20 shut. Interface serial 21 shut. Wait for the messages. Interface serial 20 no shut. Interface serial 21 no shut. Let's wait for the messages. So 2 is back up, 20 is up, 21 is back up. Show IP route. And now I'm learning my RIP prefixes. This is an example of some of the things that you can run into when you're using a virtualized environment. Because what happened was I actually took my presentation machine offline, which means it lost connectivity to the internet. And what ended up, or not to the internet, to my network. And what ended up happening is before I did that, I put it to sleep. So I rested it. And sometimes when you do that, these platforms don't come back up and they're not going to be working. So you'll run into these little spurious problems. I'll make it a point to verify that every time before we go through class. This was nothing related to the routing protocol. It's merely the fact that we're running it in a virtualization platform. However, you're going to be taking the lab in a virtualized platform, different than this one, but it's still going to be a virtualized platform. So you might need to know that sometimes when things aren't working and you can't explain why, just shutting an interface down and bringing it back up sometimes will make a difference, especially in a virtualized environment. So let's see, we've addressed that. So now let's see what happens when I take a look at one of these sniffs. So what I'm going to do is I'm going to look at the information that's coming from, I'll pick R1, interface 0, 0, and let's see what we get here. Let it open. I'm going to drag it over, and and I am going to get rid of my drawing here. So just bear with me one moment. And I'll move the drawing out of the way. And let's look and see what we got going on here. So what am I interested in? Well, I'm interested in two things. I'm interested in learning about RIP. So I'm going to type RIP into my filter. And what I'm going to see here is I'm going to see RIP version 2 messages, but I don't see any RIPng messages. Notice these are RIP version 2. We know that very clearly because we can see here that we have our source address, and we're also sending to that 224.0.0.9 multicast address, and the system even comes out and tells us that it's a RIP version 2 update. So let's erase that, our writing, and let's modify our search. So what I'm going to do is I'm going to say RIPng. Now we see our RIPng messages. Notice it's telling me everything that I would possibly want to know. RIPng tells me that it's going to be command response version 1. And notice here it's going to be sourced from our link local addresses. It's never going to be sourced from our 2001, from our global reachable prefixes. Why? Because these multicast addresses that we're using are link local in nature. They're never going to be forwarded in our infrastructure. They're going to remain on the link. So what we're going to use is these are going to be the addresses that we use to do our peering relationships, or we're going to use as the sources for our updates. We're going to find, when we look at EIGRP and OSPF, we're going to form our neighbor relationships using these link local addresses, which is why they're so important, and which is why I like to make certain that those addresses are in a human readable format. For instance, I can look here and say this is R1, this is R11. That's the reason I structure them this way. And unless you're told to do them in a specific fashion in the lab, I would highly recommend that you guys statically configure them. In the lab, if they tell you to use a specific link local address, obviously use it. But if you're not told otherwise, you will be told what global address to use. But if they leave it up to you to be able to pick your link local IPv6 address, make sure that it's something that's going to be very easy for you to recognize and understand. So with that being said, let's look at our payload. So notice right now we have RIPng, and I mentioned to you guys specifically that it uses port 521 for both destination and source. So let's look at the payload. So what type of update is this? Well, this is a response message. And when we look at it, what it's going to do is notice it's advertising the prefixes as well as giving us our metrics associated with our different routes. So let's scroll down here a little bit. And we can see, again, the specifics about each of these. So notice it's telling me my prefix. It's giving me any route tag that's been assigned. We'll talk about route tags when we get into redistribution. And we'll see the metric associated with it. So this is basically just the digest of information that we have. But we could bore down and take a look at more specific details. So right now, let me cut this out. And let's see if we can find any other messages. No, all of these are response messages. They're just being sourced from different components. So if we look at this, basically the important things are UDP port 521, source and destination, the nature of our payload, the fact that it's communicating not just the IPv6 prefix, but also the metric. And keep in mind, this is going to advertise the actual metric that's been configured, or the actual value that's been configured on the given interface for the IPv6 mask. All right, that wraps up the diagnostics associated with IPv6. Let's delve into some of the more detail-oriented behaviors and operational constraints that we can use in order to be able to fire this protocol up and make it do what we want it to do. I'll see you guys in the next presentation.